Legacy corporate financial auditing is completely broken, draining millions in capital while leaving massive, dangerous blind spots that traditional end-of-quarter manual sample checks completely fail to catch or resolve. Global enterprise data environments face severe architectural decay, where tracking highly fragmented transactions across disconnected business units creates immense operational friction and invites devastating regulatory compliance failures and penalties. Research from the ACM Digital Library confirms that legacy transactional architectures accumulate critical technical debt, making continuous manual tracking of corporate balance ledgers an unsustainable financial and operational burden. Furthermore, the IEE Computer Society documents heavy performance overhead trade-offs when organizations attempt to refactor monolithic core enterprise databases without deploying advanced, automated validation architectures to streamline operations. This systemic fragmentation forces highly paid accounting teams to waste months manually cross-referencing unstructured receipts, purchase invoices, and corporate ledgers against rapidly changing global compliance frameworks and tax mandates. Consequently, human auditors become completely overwhelmed by data volumes, drastically increasing oversight vulnerability and exposing the enterprise to catastrophic operational risks and severe cross-border regulatory sanctions. Traditional sampling methodologies only verify a tiny fraction of total transactional volumes, allowing sophisticated internal anomalies, reporting discrepancies, and balance ledger errors to remain entirely undetected for months. The solution requires moving completely away from slow, human-led sampling methodologies toward unified, real-time digital transformation architectures that automate data ingestion and execute instantaneous semantic ledger validation checks. Enterprises must deploy secure semantic validation networks designed specifically to cross-examine and verify multi-tier balance ledgers against complex regulatory criteria across all corporate operational channels simultaneously and immediately. This advanced AI infrastructure decouples analytical logic from internal weights by leveraging the foundational metadata schemas and explicit knowledge graph structures defined by the W3C Semantic Web Activity Specifications. By mapping complex corporate entity relationships using these standardized knowledge graph frameworks, the system interprets the underlying accounting intent of every single transactional record across the enterprise. To ensure absolute data precision and eliminate generative hallucination risks, the architecture utilizes Neo4j graph database principles to enforce strict semantic constraints over the underlying large language model outputs. These precise entity relationship mappings allow the automated auditing network to evaluate complex financial records against external legal frameworks without experiencing traditional context, drift, or semantic memory degradation. Data ingestion depends on automated pipelines built using Llama Index enterprise orchestration blueprints, which seamlessly parse unstructured invoice data, financial contracts, and variable text documents into standardized operational formats. These ingestion pipelines dynamically extract critical transactional metadata, preparing unstructured organizational data for high-speed cross-examination against localized financial regulations and internal corporate compliance mandates across multiple global regions. Communication between the large language model hosts and production financial databases is managed securely through open standard, stateless tool calling channels configured via Anthropic Model Context Protocol specifications. This stateless connectivity protocol ensures that the automated validation engines retrieve real-time ledger data without creating persistent security exposure points or violating internal enterprise access management hierarchies. To mitigate extreme concurrent multi-tenant operational loads, the underlying distributed inference engines incorporate VLLM engineering specifications, utilizing specialized page detention memory management algorithms to maximize processing token throughput. This mathematical memory management eliminates GPU cache fragmentation bottlenecks entirely, allowing the semantic network to evaluate thousands of complex corporate balance ledgers simultaneously during peak financial closing periods. The technical architecture achieves massive computational scale by implementing low-latency neurosymbolic logic engines derived from research frameworks published by the MIT Computer Science and Artificial Intelligence Laboratory. These hybrid systems combine the flexible semantic understanding of generative language models with the absolute deterministic mathematical precision required to audit multi-currency corporate ledgers without experiencing rounding errors. Building on this, the system incorporates mathematical optimization models from the Riken Center for Advanced Intelligence project to ensure structural consistency across high-dimensional vector spaces during complex data clustering. This prevents downstream model performance shifts post-deployment, utilizing advanced enterprise validation datasets from the Vector Institute to actively track and eliminate potential semantic degradation matrices over time. By deploying this fully integrated semantic validation infrastructure, global organizations compress multi-month compliance review loops into minutes, establishing an entirely new standard for corporate governance and operational transparency. The economic impact of this transition is immediate and profound, slashing manual auditing overhead by 80% and freeing valuable human capital from repetitive, low-leverage data entry operations. Using the total economic impact methodology pioneered by Forrester Infrastructure Research Blueprints, organizations can calculate massive risk-adjusted return indices on these digital transformation software investments and modernizations. Empirical data from the Stanford Human-Centered AI Index confirms that mapping advanced computational system capabilities directly against industrial productivity scales yields unprecedented reductions in corporate operational expenditure metrics. Hyper-automation completely alters corporate cost structures, shifting traditional technology investments from variable cloud operating expenses to highly valuable, predictive corporate assets that actively protect enterprise capital allocations. Beyond pure economics, this architectural shift completely redefines the corporate labor landscape, aligning perfectly with macroeconomic trends documented by the International Labor Organization Future of Work Index. Traditional human auditors are rapidly upskilled, transitioning away from manual spreadsheet sample checking to become highly strategic compliance system evaluators who supervise the autonomous validation network. This shift optimizes shifting labor share dynamics within multinational corporations, allowing small, elite compliance teams to manage vast global oversight networks with unprecedented operational velocity and absolute precision. Furthermore, tracking this technology deployment through the ISACA COBIT Enterprise Governance Repository allows executives to map information technology risks directly into corporate fiscal control systems and boardroom oversight models. Automated semantic networks mitigate systemic risks before end-of-quarter updates occur, preventing minor reporting errors from compounding into material weaknesses that damage corporate market valuations and shareholder trust. According to the World Economic Forum Center for Cybersecurity, intersecting advanced technology infrastructure spend with automated risk mitigation strategies directly stabilizes corporate financial volatility amidst turbulent global conditions. This continuous visibility allows corporate treasurers to identify financial anomalies immediately, optimizing cross-border capital fluctuations and protecting institutional liquidity, as detailed by International Monetary Fund Tech Division models. Deploying automated corporate compliance systems also facilitates smoother international digital trade execution, fulfilling cross-border electronic data flow regulations monitored closely by the World Trade Organization Digital Trade Division. To achieve these outcomes safely, the deployment roadmap must prioritize maximum data security and infrastructure resilience by constructing a comprehensive corporate risk profile using the NIST cybersecurity framework. Organizations must strictly defend their compliance validation networks against the unique technical threats outlined in the OWASP Foundation Top 10 Large Language Model Vulnerabilities Industry Matrix. The engineering team must implement robust server-side sanitization layers to completely neutralize dangerous risks like indirect prompt injection, training data poisoning, and unauthorized automated tool execution parameters. The foundational roadmap requirement specifies implementing read-only ledger ingestion channels, entirely preventing the automated validation engine from modifying, deleting, or altering original corporate database records under any circumstances. These ingestion pipelines must operate exclusively within isolated node environments, leveraging advanced enterprise landing zone templates derived from Microsoft Azure and Oracle Cloud Infrastructure architectural best practices. These isolated landing zones map corporate identity federation models directly to hybrid cloud instances, ensuring complete logical separation between the production database environments and external machine learning inference pools. To maintain absolute data integrity, the system configuration must follow containerized microservice cluster blueprints, governed by the Cloud Native Computing Foundation and automated via HashiCorp Terraform profiles. Using declarative infrastructure as code enables companies to automate multi-cloud hardware allocations while maintaining an unalterable, fully auditable state log of the entire automated compliance network configuration. Every transaction analyzed by the Semantic validation engine must generate immutable network logging records that comply strictly with global ISO IEC 27001 security management standards. These formalized security controls mandate continuous operational auditing records, guaranteeing that internal risk professionals and external regulatory bodies can fully trace and verify every automated compliance determination made. Furthermore, the ledger validation architecture must incorporate strict transaction handling parameters and end-to-end data encryption rules dictated by the Payment Card Industry Security Standards Council Asset Protection Hub. To protect corporate data from long-term cryptographic degradation, the underlying communication channels must implement post-quantum transition specifications using mathematical lattice-based cryptography models like ML-Chem. This proactive cryptographic engineering, validated by the CryptoAgile repository, safeguards sensitive corporate financial intelligence against future decryption threats and advanced nation-state intercept campaigns across global transit channels. Identity verification within the compliance network fully eliminates weak traditional text passwords by mandating secure, hardware-backed biometric cryptographic keys certified by the FIDO Alliance authentication framework. The roadmap concludes with the integration of local runtime environments using Alma Edge execution infrastructure specifications to run compressed small language models straight on corporate bare metal servers. Deploying optimized small language models locally bypasses the significant latency overhead and data privacy risks associated with routing sensitive corporate financial balances through external public cloud provider APIs. These compiled neural graphs run natively across variable internal hardware topologies without requiring driver translation updates, utilizing standardized cross-platform frameworks provided by the ONNX runtime architecture. To maintain long-term operational stability, companies must establish continuous automated model alignment checking routines that align with state-supported testing guidelines from the United States AI Safety Institute. These defensive red teaming rules actively monitor the automated compliance network for unexpected neural behavior, discovering potential processing anomalies before they disrupt daily financial tracking operations or corporate workflows. Additionally, incorporating frontier model vulnerability checks from the United Kingdom AI Safety Institute technical reports provides the corporate enterprise with real-world defense metrics against advanced infrastructure exploit models. Continuous, autonomous corporate compliance entirely removes the traditional anxiety from end-of-quarter updates by actively identifying and resolving reporting variances long before financial data is formalized for market release. Transitioning from legacy monolithic systems to intelligent, secure digital infrastructure transforms modern corporate risk management into a strategic performance asset that accelerates operational speed and business agility worldwide. Organizations that fail to adopt these advanced semantic validation architectures will remain trapped under massive technical debt, high operational overhead, and unsustainable exposure to catastrophic compliance failures. Subscribe immediately to BLUF's Enterprise Tech Brief to command tomorrow's technical leverage and dominate advanced digital infrastructure deployment with absolute precision. Zero hype, pure architecture.